Good morning all, my name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about Arithmetic pipeline. So, Arithmetic pipeline is a units are usually found in very high speed computers. Arithmetic pipelines are constructed for simple fixed point and floating point arithmetic operations. To understand the concept of arithmetic pipeline in a more convenient way, let us consider an example of pipeline unit for floating point addition and subtraction. So here, what is arithmetic pipeline? Suppose we have to do multiple performances. Suppose A plus B into C plus D. So it is possible to A plus B at a time and C plus D at a time. So A plus B and C plus D we can perform as a parallel. Okay. So parallel performance is going on. That is called pipelining. Pipelining means it is a systematic process to perform the arithmetic operations. It is an integer or floating point, whatever may be, but majorly we are using this method for floating point addition and subtraction. So pipelining is nothing but it is a systematic process to complete the operation of arithmetics of anything. So here A plus B into C plus D. Suppose here we need OR gate, here OR gate, and multiplication means we need AND gate. So how many gates we need? Totally 3 gates. So A plus B and C plus D is parallelly performing is possibility or not? Yes, it is possible to perform parallelly. So A plus B and C plus D will perform parallelly. And what is the result? A plus B result X and C plus D result Y. So finally what we have to do? X into Y. So what is the answer finally? So X into Y. It is a pipelining process of simple fixed point and floating point arithmetic operations. And to understand the concepts of arithmetic pipeline in a more convenient way, let us consider an example of a pipeline unit for floating point addition and subtraction. Here I am taking one example of floating point operations. So what are the inputs of this floating point adder? There are two normalized floating point binary numbers. So arithmetic operations we need definitely two inputs. We need minimum. So X I am taking and another is a Y. Suppose here X equal to A into 2 power A and Y equal to B into 2 power B. So where A and B are two fractions that represent the mantissa and small a and B are the exponents. So A and B are mantissa, A into 2 power A, Y equal to B into 2 power B. So mantissa, small a and B are exponents. So we have to balance the mantissa and exponents. So it is one example. So here X equal to A into 2 power A, Y equal to 2 power B. We have to do arithmetic and arithmetic operation and subtraction we'll do later. But we have to go for the what is the process and what are the conditions for performing pipeline arithmetic. So the concept of a arithmetic pipeline revolves around the principle of overlapping the execution of different arithmetic instructions. Instead of waiting for each instruction to complete all stages before starting the next one, an arithmetic pipeline enables the processor to initiate the execution of a new instruction while the previous one is still in processing through the pipeline stages. The pipeline stages involved in an arithmetic pipeline typically include what is one? First one, fetch. In this stage, instructions are fetched from memory or cache and loaded into the pipeline. So first one, it is the arithmetic process, arithmetic operation. That revolves around the principle of overlapping the execution of different arithmetic instructions. Instead of waiting for each instruction to complete all stages before starting the next one. An arithmetic pipeline enables the processor to initiate the execution of a new instruction while the previous one is still processing through the pipeline. Suppose A plus B into C. So we have to do multiplication here. So, but multiplication will perform after the completion of this addition. So, if we get the result of A plus B, then only we have to perform this one. If we get the A plus B answer, definitely after getting this answer, then only we have to multiply with C. So, we have to wait for this some time to initiate the execution of new instruction. So, when some multiple instructions are there, every instruction of the next instruction is waiting for the previous instruction of the result. Then only next instruction should be complete. And the pipeline stages involved in arithmetic pipeline typically included fetch. Fetch means it is the stage instructions are fetched from memory or cache and loaded into the pipeline. Suppose I am going for one arithmetic operation. Move ax comma bx, add ax comma bx, and into 0 3. So how many instructions are there here? I am taking here 3 instructions. So when I am going for execution of this one, these three instructions should search from memory. It is fetched from memory. Why? Because what we given the instructions, these are in memory. Okay. Fetching means what we typed the instruction, what we are executing the instruction, those instructions are already in memory. So while executing of these instructions, when fetching, execution time means first fetching, in the execution first stage is a fetching. So these fetching, the instructions are fetched from memory. Where is the memory means what I saved the program. These instructions where we saved. What is the address? Memory and address. Memory with address. So first it will go to these instructions or go to address. Then only it will be find out is that where is the exact memory of this one. So first fetching the instruction from the memory or cache and loaded into the pipeline. Okay. After fetching this memory, okay, what are the instructions are there in the memory? It will be matched. Then it will be cached or loaded into the pipeline. Pipeline means the process should be stopped. So after the fetching, what is the second condition? Decode. Decode means the fetched instructions are decoded to determine the type of arithmetic operation to be performed and the operands involved. Execute. This stage performs the actual arithmetic calculation or operation on the operands. It involves operation such as addition, subtraction, multiplication and division. Write back. The result of this arithmetic operation is written back to the appropriate destination. So how many stages here? Fetching, decoding and write back. So fetching means already we discussed here. The instructions are fetched from the memory and it should be loaded to the pipeline. Next, decoding means what are the instructions are there that should be converted to the binary. Why? Because it will convert it to the machine language. Machine level language. So machine level language means definitely we have to convert to the binary. So how we are converting to the binary? This binary process is called decoding. So what are the fetched instructions are there in the pipeline? Those fetched instructions are decoded. Suppose here I typed 3 instructions. Move ax comma bx, add ax bx into 0 3. So these 3 instructions we fetched from the memory. After fetching these 3 instructions, what is the next step? It is going to the decode, means converting to the binary. To decoding this, determine the type of arithmetic operation to be performed and the operands involved. After the completion of this decoding, what is the process? What is the process means? Here I have to go for addition. So addition I have to go. So the related logic gates to be activate And how many registers I defined? 2 registers I defined. So definitely I need 2 registers with one arithmetic operation, that is AND. Add means what we need? Add means we need OR gate. So related that gate should be called. Then it will be performed and the operands are involved. So operand means what are the operand? And, add, mul, div, sub. So these are the operands. Means multiplication, addition and division, and these are the arithmetic operations should be operands should be involved in the arithmetic operation. After the fetching, the decoding should be determine the type of arithmetic operation and to be performed and to be called the how many registers are related to that one and what are the operands. After the decoding, it should be executed. So these 3 lines should be executed. In this stage, the performance of actual arithmetic calculation or operation on the operands involves operation such as addition, subtraction, multiplication or division. So what you call the function? Suppose my operand is AND or add operation or sub operation or mul or div operation. So what it may be? There are 4 types of arithmetic operations are here defined. So this execution state, what you defined? Suppose I defined here add means addition. So definitely in the execution time, the addition should be processed. The actual arithmetic calculation, the operation of the operand involves operations such as addition, subtraction, multiplication or division. So after completion of execution, so I'm executing my operands or my instructions, then the result of the arithmetic operation is written back to the appropriate destination. So my execution is completed. What is the execution? Addition of 2 numbers. So addition of 2 numbers we have to execute. So the result of the arithmetic operation is written back to the appropriate destination. Then they will ask what is a value. Suppose I am giving a equal to 4, b equal to 3. Add means 4 plus 5. So the result should be come. So it is a write back operation should be performed to enter the inputs and we'll get the output. It is about the arithmetic instruction. And what are the advantages for arithmetic pipeline? Increased throughput. The ability to process multiple instructions simultaneously enhances the overall throughput of the system as more instructions can be executed within a given time frame. And reduced latency. The overlapped nature of the pipeline stages reduces the time taken for an instruction to complete, resulting in lower latency and improved responsibilities of this one. So first increased throughput. When I am going for the arithmetic pipeline, how we are increasing the throughput means the ability to process multiple instructions. So what are the multiple instructions? Previously I took 3 instructions. So these multiple instructions simultaneously enhances the overall throughput of the system as more instructions can be executed with a given time frame. So what is the exact meaning of throughput means? Multiple instructions should be executed within a short period of time. That is the throughput. In a less time, more instructions should be executed. And reduced latency. The overlapping nature of the pipeline stages reduces the time taken for an instruction to complete, resulting in lower latency and improved responsiveness. But that means latency. The overlapping means one instruction to be overlapped to the another. So these pipeline stages reduces the time taken for an instruction to complete. So what are the overlapping are there? It will be reduced the overlapping and we are reducing the time taken to execute the instruction and results in the lower latency and improved responsiveness. So increased throughput is one good thing and reduce the latency is the another good thing for arithmetic pipeline. And resource optimization. Pipelining allows for efficient utilization of computational resources. The processor remains busy most of the time as idle stages are filled with new instructions, maximizing the utilization of hardware resources. So how we are utilizing the resources of the arithmetic pipeline. So the computational resources like the processor remains busy most of the time to idle stages are filled with new instructions, maximizing the utilization of hardware resources. So multiple operations should be performed. So how we are utilizing? Suppose here I'm going to for the parallel processing. So are you utilizing this parallel processing? Yes, I am utilizing this parallel processing. So when the processor remains should be busy or it should be in the time as idle state, then new instructions should be utilizing and maximizing of the hardware resources. How much you are utilizing of the processor is also important, and what are the new instructions you are defining is a important thing. And improved efficiency with the execution of multiple arithmetic instructions in parallel, the arithmetic pipeline improves the overall efficiency of the processor, enabling it to handle a higher number of instructions per unit time. So for example, I have to go for 3 instructions should be executed. So these execution of multiple arithmetic instructions, example 3 instructions in a parallel, A plus B and C plus D, and go for the 2 parallel operations. The pipeline improves the overall efficiency when multiple inputs or multiple instructions are parallelly processed through the processor. Then we are improving the efficiency of that one and enabling it to handle higher number of instructions per unit time. When parallel process is going on, multiple instructions should be overlapped. Multiple should be enabled to handle the higher number of instructions as per unit time. In a given particular time, the more number of instructions should be executed with the parallel processing. Okay, that is a improved efficiency. So these are the advantages of arithmetic pipeline. And the combined operation of floating point addition and subtraction is divided into 4 segments. Each segment contains the corresponding sub operation to be performed in the given pipeline. So the combined operation of floating point addition. Floating point means suppose I am taking 1.24, 5.08 example. So these are the floating point addition, subtraction. These are the floating point values, and they are the pipelining process in the floating point addition and subtraction. We are dividing into the 4 segments. Each segment contains the corresponding sub operation to be performed in the given pipeline. So what are the segments containing with the sub operations to be performed in the given pipeline? First, these sub operations are shown in 4 segments. First segment, compare the exponents by subtraction, align the mantissa, add or subtract the mantissa, normalize the result. Okay, in the previous slides we took one example of this one. Suppose x equal to a into 2 power a, y equal to b into 2 power b. Here a and b are the mantissa and these are the exponents. Like this, what is the first condition means? Compare the exponents. Compare the exponents. Suppose 1.24 into 10 cubed. Okay, and plus I am adding with another 5.08 into 10 square. So these exponents are balanced? No. Here 10 cube is there, here 10 square is there. How can you balance this one? Okay, so we have to change to this is 10 cube or either it is the 10 cube. Okay, if both exponents are equal, then only addition and subtraction is possible. So both exponents should be balanced equal, otherwise it should be not to perform addition or subtraction. And align the mantissa. So here 1.24 is there, here 5.08 is there. After the digit, before the digit, 1 digit only, here also 1 digit only. After his 2 digits are there. So is it balanced? Yes, the mantissa is balanced. Then no need to align. If align is not balanced, here 1.24, here 15.08. So what we have to do? We have to balance. So like 1.508. Otherwise, we have to take here 1.24, here 15.08. 12.4 like this. Okay, 12.4 into 10 square plus 15.808 into 10 square. Okay, these exponents are balanced. Yes, exponents are balanced. Mantissa is also balanced. Then it is possible to add or subtract, and add or subtract the mantissa. When it will be possible means exponents are balanced and the mantissa should be balanced. Then only possibility of subtract and mantissa, and normalize the result. The result also should be managed as a mantissa and exponent should be balanced. A equal to 5.08 into 10 cube. B equal to so we have to go for A plus B. What is the A here? 5.08 into 10 cube. So what is a mantissa here? 5. What is exponent? 3. So in the B, what is a mantissa? 15. So here 1 digit of mantissa, here 2 digits of mantissa. Here only 1 digit. Here 2 digit of mantissa. Here exponent is 3. Here exponent is 2. So we can observe first what is the first thing? Compare the exponents. Exponents are here 3, here 2. Is it balanced? No. These exponents are not balanced. So we have to balance. And we have to observe here mantissa is 1 digit, here 2 digit. What is the process? Align the mantissa. So if equal, if balanced, don't need to align. If not balanced, then we have to align the mantissa. Then you can perform add, subtract, then normalize the result. If these are not balanced means first we have to balance. Suppose here I am taking 5.08. So 50.8. 0 digit I will take here 10 square. Okay. Is it okay? Yes. Next. B equal to 15.24 into 10 square. Why? Because this 10 cube is there now. I change it to 10 square and 10 is changed to 50.8 into 10 square, 15.24 into 10 square. So these exponents are balanced and the mantissa is a 2 digit. Okay. Then perform. If mantissa and exponents are balanced, then only perform addition or subtraction. Otherwise, we can't perform. So 50.8 into 10 square, 15.24 into 10 square. So mantissa are 2 digit and exponents also balanced. Then I can perform A plus B. 50 plus 15. So we can do like this. 0 plus 4, 4, 8 plus 2, 10, and 0 plus 5 plus 1, 6, 5 plus 1, 6. 66.04 into 10 square. Okay. Then normalize the result. Results also you should be normalized. Why? Because here 2 digit of mantissa in A and B. The result also we can balance. The result is a 2 digit, and here exponents are 10 square. 10 square means 2. Exponent value is 2. Here also exponent value is 2. The result also we have to balance with A and B like, and here also 2. So 2, 2, 2 balanced. Here mantissa digit is 2 digit. 2 digit. Result also we should maintain 2 digit. Then is it successful? Yes, it is the successfully we have completed the arithmetic pipeline. Next, the following is a block diagram represent the sub operation performed in each segment. First, I am taking the exponent here mantissa. Exponent means here what is exponent value is 2 2 like this. So or is a exponent value. Compare the exponents by subtraction. If I am going for the A minus B. So what is the subtraction? A into 2 power A, B into 2 power B. So compare the exponents. These exponents I have to compare. A greater than B or A equal to B or A less than B. Compare and choose the exponent. So here we have to balance A equal to B. A equal to B means we have to balance the exponent. Then adjust the exponent. Then what is the result? Here first one is A equal to A, here B. Suppose here A equal to 3, here 2. Is it balanced? No. After getting what? We have to go for 2 equal to 2 or 3 equal to 3. We have to change this 3 to 2 or 2 to 3. Two options are there. Then we can adjust the exponent. Then we can finalize this one. Segment 1 comparing. Segment 2 exponent is choosing. Segment 3 adjusting the exponent. Segment 4 finalizing the exponent value. And here mantissa means A and B. Here suppose A equal to 2 digit value, B equal to 1 digit. Is it balanced? No. Align the mantissa. alignment is important. To perform here 2, then only you can change to 2. Here 1, then only you have to change to 1. 2 to 1 or 1 to 2. You can change or balance the Montesa. And first one, align the Montesa, add or subtract the Montesa, normalize, and then balance. So here this step, exponents are balanced. Here Montesa is balanced. Exponents are balanced. Montesa is balanced. Then only perform a plus b or a minus b, what it may be. So here I am taking one example to perform arithmetic pipelining. Compare exponents by subtraction. The exponents are compared by subtracting them to determine the difference. The larger component is chosen as the exponent of the result. The difference of the exponents, that is 3 minus 2 equal to 1, to determine how many times the quantity is associated with the smaller exponents must be shifted to the right. So we have to balance a equal to 2 power a, b into 2 power b. So we have to balance the exponents and Montesa. X equal to 0.9504 into 10 cube and y equal to 0.8200 into 10 square. Here exponent value is 3, here exponent value is 2. So align the Montesa. The Montesa is associated with the smaller exponents shifted according to the difference of exponents determined in segment 1. X equal to 0.9504 into 10 cube, y equal to 0.0800 into 10 cube. But this 10 square is changed to 10 cube. What will happen? 0.8 is changed to 0.08. So what is the Montesa digit here? Montesa equal to 1. Here also Montesa equal to 1. Montesa equal to 1. Here exponent 3, exponent 2. But here exponent 3, exponent 3. So are we balanced? As exponents balanced. And Montesa aligned. So exponents are balanced. Montesa is aligned as 1 digit. Then we can perform a plus b or a minus b or addition or subtraction. So add Montesa. Z equal to x plus y. X plus y. We have to add 1.03. How we are getting means x equal to 0.9504 into 10 cube, y equal to 0.08200 into 10 cube. So exponents are balanced. Then no need to examine. So here 4 plus 0.08200. How many digits? 1, 2, 3, 4, 5. Here 1, 2, 3, 4. So last digit 0 I should be removed. So here I should be remove 0. So 4 plus 0, 4, 0 plus 2, 2, 5 plus 8, 9 plus 1, 0 plus 0 plus 1, 1.0324, 1.0324 into 10 cube. So normalize the result. Why? Because here 0 point is there, here 0 point is there, but output I am getting 1 point. Is it normalized? No, the Montesa is not the normalized. Why? Because in the previously x equal to 0 point something, y equal to 0 point something, but I am getting the answer 1.0 something. So I have to normalize the result. Well, because it is the 1 point is there, so it is changed to 0. So what I have to do means I will shift it to this one here like this. So 0.1 I shifted here, 1324 or 10324, then 10 power 4. Why? Because it is shifted to here now. So 10 cube is changed to 10 power 4. So I normalize the result as like this. Otherwise, you can keep 10 cube and 1.34. Even the exponent value should be balanced or the Montesa should be balanced. It is about the arithmetic pipeline. So today we discussed arithmetic pipeline should be performed in simple fixed point and floating point arithmetic operations with Montesa and exponent. So what are the conditions? Means the pipeline stages are involved in the arithmetic pipeline. Typically fetching means we are fetching from memory. Decoding means after fetching the instruction from memory, we are decoding means converting the binary to determine the type of arithmetic operation. Which type of arithmetic operation is I have to perform and what are the operands are mentioned in the instruction. And execution means after completion of decoding, we have to go for the execution of the instructions to perform arithmetic operation. So is it addition or subtraction or multiplication or division? So after completion of executing, we are write back means the result of the arithmetic operation written back to the appropriate destination. Means after completion of this program, like a equal to 4 I given, a equal to 5 given, add 4 plus 5, 9, I got the result. So after completion of this one, it is get back to the result of the arithmetic operation and return back to the appropriate destination. So what are the advantages of arithmetic pipeline? Increasing the throughput, reduced latency, resource optimization, and improved efficiency. These are the advantages of arithmetic pipeline. And how we are combining the operation of floating point addition and subtraction. There are 4 conditions are there. Compare the exponent by subtraction, align the mantissa, add or subtract the mantissa, normalize the result. So these are the 4 stages are there for or 4 segments to perform arithmetic pipeline. It is a flowchart of exponent and mantissa, and it is the stages to perform arithmetic pipeline. First stage, compare the exponents by subtraction, and second one, align the mantissa, add mantissa, normalize the result. Okay, it is about the arithmetic pipeline with suitable example. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.